Hello, welcome to our series Manage Well and Get Preserved about digital preservation of research data. This time we're going to talk about what information is needed to preserve digital research data in the long term. There are things that are good to be aware of when you start planning your data management, if you want your data to be eligible for preservation. If you think about these details in the early stages, it will be much easier to prepare your data for preservation. We hope this video can help you take good care of your research data. So good that it can be reused and preserved even for future generations of researchers. Over years and decades, formats and media for storing digital information break and become obsolete. There are different strategies for managing this. Either data and software can be migrated to new formats as technology develops and old media decay or become obsolete. Or one can try to keep old technology alive in museums and archives, or recreate old environments virtually. This is called emulation. As mentioned, everything, for example hardware, software and file formats, will eventually become obsolete. Therefore, it is important to use commonly used file formats that are open and well documented, so that the technical information of the content remains understandable. We need to know what information is stored and how it is represented, in which format it is, and which traits are important for understanding and using the data in the future, maybe in a very different environment. Take, for instance, a picture file. It contains a lot of technical metadata. We need to know how the colors are coded and pixels should be rendered in order to be able to know how it should be displayed in a correct way, even if all software has changed.
Okay. Now we have established that we need a lot of information about the datasets to preserve them properly. But what kind of information should we consider? Well, there are different types of metadata. These are descriptive metadata that describes the semantic contents of the dataset. Technical metadata describing the important technical aspects of the format the dataset is stored in. Digital provenance metadata describes the life cycle of the dataset. And structural metadata describes the structure and how different files relate to each other within a dataset. When a research dataset is sent to the digital preservation service, the goal is to have the data as self-sufficient as possible. That means that the files in a dataset are packaged together with all relevant metadata, be it descriptive, technical, structural, or relating to the provenance of the data. These packages are commonly called information packages, and they are automatically created in the FAIR data packaging service. In order to be able to preserve digital contents, you need to know what you have. Not only knowing the contents, but also in what format your data is stored in. To facilitate preservation actions, it is important to know the file formats the data is stored in, as well as the technical aspects of the files. Does it contain text in a structural format? Does your dataset contain images? And if it does, are the images in color, and is the color profile important for understanding the data in the future? Metadata about file formats and the technical aspects of a file is commonly called technical metadata. This metadata can often be extracted from the digital files themselves. Without technical metadata, it is very difficult to determine when a file is in danger of becoming obsolete due to the file format falling out of use. And in order to know how a file should be migrated to a new format or emulated properly, you need to know the technical aspects of that file and its format. Another aspect of technical metadata is information about a file's integrity. When preserving digital contents, it is imperative that the files themselves are not unintentionally changed or modified. Having metadata about a file's integrity, like a checksum calculated from the file, is a way to ensure that you can always check whether the file has been altered or not by calculating the checksum again and comparing it to the checksum information stored in the metadata. We will have a separate webinar about file checksums, so be sure to check it out when it is published. During digital preservation of contents, so-called preservation actions have to be performed in order to ensure that the digital contents are preserved safely and that they remain usable at all times. These preservation actions can be actions that ensure that the preserved data is safe and secure. For example, fixity checks. However, actions pertaining to the creation of the file, its accession into a digital repository, and other actions relating to the curation of the contents are of equal importance. These actions need to be documented in the provenance metadata of a file. The documented actions are typically called events. When documenting these events, it is important to document what was performed, that is, what is the type of event, when the event was performed, by who, usually software, which is called an agent, and which digital object, the data files, that were affected. For example, when calculating the checksum of a file, it is important to also document when this happened, as ensuring that the file is not altered is possible only from this timestamp onwards. Another example is documenting the circumstances regarding the creation of a file, which software and hardware, if necessary, what settings are used, etc. This is information that can be vital in the future when trying to understand the characteristics of the file, why it looks like it does. And it is often required to be documented by the creator of the contents itself, as this is information that cannot be deduced from the files. The Finnish National Digital Preservation Services have published a set of preservation event types that are recommended to be used. And the Fair Data Metadata Service, Metax, has also incorporated a set of lifecycle events types into its vocabulary. You can find the relevant links below in the video description. And for example, an event can be a migration, which is a conversion of a file in a format that is not suitable in the long term to an open and stable format. Research datasets can be complex sets with lots of different files relating to each other. For example, the raw research data stored in a database or other binary format might require processing algorithms or executable files to be able to be processed and understood. Documentation of the data structure and the search algorithms used by the research project is also often necessary to be included in a preserved dataset. Documenting the relationships between files in a set is commonly called structural metadata. Metax defines use categories for files, assigning them a role, explaining their use type in a research set. You may use the following categories available in Kuvain to describe your content: source material, outcome material, publications, documentation, configuration files, method descriptions, and rights statements. Okay, so how do we combine all of our metadata and the content into a self-sufficient information package and send it to the Digital Preservation Service? Well, the files of a dataset can be stored in IDA service, and the corresponding metadata can be described with Kuvain, which is then stored in Metax metadata warehouse. Or alternatively, the files can be stored in the pre-ingest file storage service and the metadata directly to Metax by using its interface. When a research dataset has been proposed and approved for preservation with the management service, the packaging of the dataset for digital preservation can be started. The packaging service automatically fetches the actual content from the IDA service or from the pre-ingest file storage service. and the metadata from the Metax metadata warehouse. The packaging service will also produce technical metadata along with the package itself by analyzing the technical features of the files. It will automatically transfer the data to the service. You are able to see ingest reports from the management service, which describe that the datasets have been accepted for preservation.
Thank you for watching. We hope this was a helpful introduction to preservation metadata and why it's important in research data management. The FAIR data services can help you with choosing suitable metadata for preservation. If you are unsure, you're always welcome to contact our digital preservation services. Next time, we will talk about managing and naming files. See you then.